Here are a few scenes that tell better than words what this sport is all about. There's no lower cost or nicer way to spend time than sailing, and there are few things in the world that are as quiet, graceful, romantic, and just downright fun. There's a lot of interesting stuff on the oceans and waterways. This is an offshore oil rig. Environmentalists hate them, but they make great racing marks, especially at night. Many shorelines are loaded with wonderful restaurants. These can really brighten a voyage. Sailing should not be without luxury. The big dome is where the Howard Hughes flying boat was kept. This is the Queen Mary, landlocked. There are thousands of quiet coves, anchorages, and secluded waterways. You can get away from the crowds. The boat's a great camper. Stay here overnight. Better yet, anchor on this pretty lake near Yellowstone in Idaho. Anchor it here as long as you want, for free. Launch it at this ramp for $2 and play on the boat forever. This is the Newport to Ensenada race. There are 500 sailboats out here milling around prior to the start. It tows well. Even dolphins like to play with it. We go for a sail and come back to this, taking over the dock. Now what? This is the Lynx, a replica of an 18th century revenue cutter. The 26 is built in one of the most modern and efficient plants in the industry. We rely heavily on computers in all areas of the business. We use state-of-the-art computer modeling for all design work. We start, like the ancients, with two-dimensional 3-view drawings. Each piece of the boat is then converted to three-dimensional line models. Computer simulations are made of every piece of the boat. The pieces are then combined into a complete 3D model. The computer then forms perfect surfaces over the skeleton. This is how Boeing created the 777 airliner. These surfaces are then transferred to a computer-controlled gantry router, and the full-size shapes are formed to better than 0.003 of an inch tolerance. Here, our router is cutting the surface of the mock-up of the sliding hatch. Now it's cutting a rudder shape. Here it's carving in high-density foam the shape of the front window area of the deck. The computer-cut pieces are assembled to form a mock-up of the deck called a plug. It's given a perfect finish. A fiberglass mold is then laid up over the plug. This is the finished plug for the hull. These are the fiberglass pieces that make up the boat. This is the nearly finished hull shell, still in its mold. You can see the molded-in water ballast tank and the stiffeners. Next, I'll show you the materials that make up the boat. This is woven fiberglass roving. It provides the basic strength for the laminates. It will take loads of 35,000 pounds per square inch. This is unidirectional glass. It has all the strands going in one direction. This is fiberglass mat. It's made up of short fiberglass filaments. It holds a lot of resin and provides stiffness and rigidity. This is fiberglass cloth. It gives a smooth interior surface and provides strength. The fabrics are cut to exact patterns. 20 layers are cut in a single pass. The pieces are made up into kits in the order in which they're applied to the boat. We start with a highly polished and waxed 3-ton hull mold. The boat is built from the outside in. The areas for blue are masked off. This gun sprays both catalyst and gel coat. The catalyst causes the gel coat to harden. Gel coat's a pigmented polyester resin. The masking is removed, leaving a window for the blue. The blue gel coat's then applied. The first layer is laid down and wet out with resin. Rollers, squeegees, and brushes are used to remove any air bubbles and excess resin from the laminate. This is where the real quality of the boat is determined. After the first layer cures, additional layers of fiberglass mat and fiberglass roving are added. They are wet out with a spray gun and all air is removed from the layout. Here are reinforcing pads being added for a mast support attachment point. Additional layers of mat and roving are applied until all areas of the hull reach their proper thickness. The tan gel coat's being sprayed on the hull liner mold. This is the finished hull liner before it gets bonded into the hull. The liner hatch cutouts are trimmed, and the finished liner is bonded and fiberglassed in place. After the resin hardens, the hull is removed from its mold. Notice the molded-in stripes and the high gloss on the exterior. If the hull mold surface is perfect, the hull surface will be perfect. Here's the deck mold shop, neat and tidy. The deck mold is covered where the black windows will be, and it's ready for white gel coat. The non-skid texture is built into the deck mold. The deck is sprayed with white gel coat. The masking is removed very carefully before the white is cured. Black is then sprayed on the window area and over the entire deck to make it easy to spot air bubbles during the layout process. The first layers of fiberglass fabrics are laid out on the deck's cured gel coat. This is the first layer of the deck. All of the air is being worked out. And the first layer is allowed to cure. This is the finished deck with all its layers and reinforcements in place. This is a deck liner mold. And a finished deck liner. The cured deck is being removed from its mold. No further work needs to be done on the outside surface finishes. It even comes out of the mold waxed. These are rudder molds. Here's a drill fixture that locates the holes for the deck hardware. Simple but foolproof. The steel bushings place the holes exactly where they should be. This larger jig lowers to locate the holes in the cabin top. It also guides the diamond-wheeled routers that cut out the windows. This diamond-coated saw trims the edge of the hull. This fixture is used to exactly locate the holes in the aluminum masts. We have a lot of automation. Here an overhead gantry router